My name is Jeroen de Bakker and I am a PhD student in production technology at University West, and I work with automation and robotization of friction stir welding. In friction stir welding, we start with two workpieces. You also need a welding tool which penetrates into the material. As soon as you start penetrating, the combination of rotation of the tool and the force will create frictional heat at the interface between the tool and the workpiece. This frictional heat will correspond to a certain welding temperature. The temperature in here will cause a diffusion of electrons due to the thermoelectric effect towards a colder point. This will cause certain voltage difference between the hot and the cold point in both materials. So if we would measure the voltage between the cold point in the aluminium and somewhere at a cold point in the steel, there will be a voltage difference. This voltage difference corresponds to your temperature inside the weld. So by measuring the voltage, you find the information from the welding temperature. The main advantage is that you don't need any extra sensors, like sensors inside the tool or inside the workpiece. It is the tool together with the workpiece that create a sensor. So it makes it easier to implement, and it's also cheaper than most other temperature measurement methods. Another advantage is that you can use this method during welding as online temperature measurements, which makes it possible to use it for online control. For example, controlling the downforce or the rotational speed of the tool. When you can do that, it makes it possible to weld more complex geometries and makes the process more robust.